So let's talk about logarithm. When you hear about the word logarithm, what comes to your mind? Well, logarithm is just like a way of writing an index. Just let's say another way. Okay, and it actually has a definition. And what says the definition? Okay, this is that logarithm of a number is an index to which a number base is raised. So this definition is being interpreted in this form. So the form log of a, let's say log of base a to b is equals to c. Then the value of this expression can be expressed further in the form a to the power of c equals to b. So the value of b here, whatever b is, will be equals to the index of a, such that the index of a will be c. So that's exactly what the definition of logarithm is trying to let us know. So let's try to take an example. For instance, let's say we have log of 2 to x, and the set is equals to 4. So, and we are being required to solve for x. All we need to do is to set x to be equals to 2 to the power of 4. So the base will be raising the value. So definitely x will be equals to 16. So this expression, these values are derived from the definition of logarithm. So now, unlike indices, there are some basic rules that you need to work with when dealing with problems involving logarithm. Okay, once you're familiar with these laws, then you are good to go. So now let's talk about them after the other. Hopefully you are within this. Let me get rid of it. Okay, so the first one is the product law. When we have a logarithm of two certain numbers to be multiplying themselves, what can we do? Is there any other way in which we can rewrite this or express this? So here's it. So if you have log of a certain base, let's say base a. So let's say the function is xy. So xy are two variables that are multiplying themselves. Okay, so for the product law, this is simply equals to, all you need to do is to set the logarithm, okay, with the corresponding base associated with each variable. Okay, you just need to separate them. Then you need to insert a positive sign. So plus log of base a to y. So just keep that in mind. If you have a logarithm of a number, okay, whereby you have two different variables multiplying themselves, okay, you can just distribute that log with the corresponding base for each of the variables. Okay, so the next one is the quotient. When I have two different functions to be divided themselves with a certain log, what would that be equals to? Let's consider the same scenario, x and y. So this simply equals to, you're actually going to do the same thing, but it's just that the only difference is the different sign. Okay, instead of having a positive sign, you'll be having a negative sign. So log of a to x, then minus log of base a to y. All right. So now the next one is the identity. Let's say you have something like this: log of 10 to the power of 10. This simply equals to 1. Whenever you have a log of a certain value, such that the base at which the log is the same as the value, and this simply equals to 1. Okay, now there are some situations whereby the function, let me say either the function or the base, will be associated with an index. They will be raised to the power of a certain value. In that case, is there any other way in which we can express them? Yes, there is. So let's try to figure them out. Okay, hopefully we are written this, so I need to get rid of it in order to create a little more space. Okay, so what I'm saying in essence is that what if you have something like this: log of a and let's say b to the power of x. Okay, all you need to do at this point is to bring the exponent or the power to the front of the logarithm, such that it will be multiplying the log in the general form. So this simply equals to log of, it will now be x times log of base a and to b. Okay, Now the next one is, what if we have a to be raised to an index and not b? Is there another way we can express that as well? Yes, there is. So if you have something like this, log of a to the power of x, then of b equals to, what will it be equals to? So instead of bringing x to the front as a whole number, okay, x will come to the front as a reciprocal. What am I saying? Is going to be in this form: 1 over x times log of is a to b. So you need to keep it in mind. Take note of those 2 key points. When the variable or the function is raised to an index, then the index can come to the front of the logarithm and it will be acting as a whole number. But when the base is raised to an index, the index can come to the front of the logarithm, or it will be acting as a reciprocal. So you just need to make sure you are familiar with that. Okay. So the next one is the change of base. What am I saying? Let's try to figure it out with some visual illustrations. So let's say you have a log of a certain number with a particular base. Let's say log of x to p. Okay. Is there any other way in which you can write this such that you will be, let me just shift this a little bit, okay? All right, so that there will be enough space in which you will be able to change the base. Here's the case. In this case, this simply equals to, let me say I just want to change the base from x to a base of c. This will be equal to log of base c, okay, to p divided by log of base c to x. Okay, so the last law or the last rule or the last thing you need to be familiar with when it comes to logarithm is when you have something like this: log of base x to b. This is also equals to 1 over log of base b to x. Okay, proof to all this formula are going to be enlightened. Okay, videos on them are going to be created. So those are the basic things you need to be familiar with when it comes to logarithm. Okay, this will be the part 1. The part 2, we're going to be applying all these laws and rules into a practice problem. Thanks for watching STWT. If you haven't subscribed to my channel, please try to do that now.